Has she rejoined again?
No, sir, I think she had network issue.
Pardon?
No, sir, I think she had network issue.
No, I can see here 13 participants, but when I checked, we are only 12. Acha, we are there, I think. 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll see. See. What is charge of one electron? Charge of one electron in magnitude, it is 1.6 into 10 raised to minus 2 electron. Okay. So when you see, say, electrons are lost or gained, then it can be 1 electron, 2 electron, 3 electron, 4 electron, 5 electron. Can it be 0.5?
No.
No. So always the charge is due to loss or gain of an electron. If lost, then plus Ne will be charged, and gain then minus Ne. So n is integer. Such type of multiple is called integral multiple. So integral multiple is called quantized. So we can say the charges are always quantized, that is they are integral multiple of charge of one electron. So sometimes they can say, what is meaning of quantization of charge? Charges are due to loss or gain of integral multiple of electrons. This is called as quantization of charge. Therefore, Q is plus or minus Ne. Okay, right. Q equals to plus or minus Ne. Okay. One question will write. A body has charge of plus 2.4 coulomb. Find the number of electrons lost. SI unit of charge is coulomb. So we want, if it is 2.4 coulomb, how many electrons are lost? So Q is Ne. N is Q by E. So Q is 2.4 Electron charge, we have to remember 1.6 into 10 raised to minus 19. 8 threes are 24. 8 twos are 16. So 1.5 into 10 raised to minus 19 number of electrons are lost. Write down.
It should be plus 19.
Plus 19 is correct. Plus 19.
So,
Yes.
so yesterday's paper, last 45 to 41 to 45 questions, something was asked about resolving power of
Yes, yes,
microscope.
yes. Actually, that is a well standard topic. So those four
So, sir,
questions,
didn't solve it. So, okay.
no need. We will have, we will remove that much for while
Okay, sir.
correction now. The last moment it is difficult to adjust, therefore I didn't answer. But those marks will not be counted. So we'll take only first 40.
Thank you, sir.
Done, sir.
Okay. Second question. How many electrons must be lost or gained how many electrons must be lost or gained to obtain charge of 1 coulomb? You all try this. Let me see whether you get correct answer.
It's 6.25 10 to 18.
Correct. I wrote 10 upon 16, which I can further write 100 into 10 raised to 18 upon 16. 6.16 6 are 96, remainder 4, 16 into 2 32, remainder 8, 16 into 5. So 6.25 into 10 raised to 18 electrons when lost or gained, charge is said to be 1 coulomb. Completed?
Done, sir.
Okay. State law of conservation of charge. State law of conservation of charge. Which conservation you have studied earlier? Energy. One more you studied this year. Law of conservation of momentum. This is third we are studying. Law of conservation of charge. Conservation means it is created or destroyed. Conservation means what? Created or destroyed? Neither created nor destroyed. Huh?
Preserved.
Preserved. So it should remain constant. So total charge of entire system will remain constant. One will give, other will take, but it will not create anything. So statement is like this. The charge can neither be created nor destroyed, but it can be transferred from one body to another body. But it can be transferred from one body to another body. Total charge of an isolated system always remains constant. Isolated means individual system always remains constant. Suppose this is body A having charge of plus 6 coulomb. This is another body of charge minus 4 coulomb. When they are touched together, then total charge will become minus plus 6 minus 4, that is 2 coulomb. So total charge will not change, it will remain same. Now when I separate these two bodies again, then each will acquire half of charge, 1 1. But total is again 2. What was earlier? Hello? Hello?
2.
So whenever two different bodies, same surface area, are touched together and separated, then charge will get equally divided. Irrespective of whatever charge they had earlier, after touching it will be equally divided. That means total charge at the start, total charge at the end remains same. That is called law of conservation of charge. Any doubt? Hello?
No.
Any doubt?
No, sir.
No, sir.
No, sir.
Okay, copy the statement and below that write that example. I give that example because sometimes problem is asked based on that type. The charge can neither be created nor be destroyed, but it can be transferred from one body to another body. Yes, done, Paul?
Yes, sir. Done.
Okay. How many types of charges are there? How many types of charges we got?
2.
Two. Which are they?
Positive and negative.
Positive and negative. So there are two types of charges. That is positive charge and negative charge. Positive and negative. Positive, positive or negative charges are called as like charges. So when they say like charge, what does it mean? Either both are positive, either both, no, nature I am telling afterwards. Either both are positive or both are negative. They are called like charges. So two positive or two negative charges are called as like charges. They repel each other. They repel each other. Positive, negative or negative, positive are called as which charge?
Like that.
Unlike charges. They always attract each other. They always attract each other. See, to attract or repel, we require one physical quantity acting between them. Can you tell which physical quantity to attract or repel? Which physical quantity we require? Length, mass, time, temperature, speed, what we require?
Charge.
No, charge is already there. Between these charges, to attract or repel, we require force.
Force.
They won't get attracted, repelled on their own. Something should be there, no, present in between. That something which is pulling them or pushing them is force. There was one movie called Three Idiot. You have seen that? I think we all might have seen. If not, then you have to see at least 2-3 times. In that, the professor asks, "Tell me how the motor starts." The person he had not studied how the motor starts. He says it starts like this. So if somebody says how the charges attract, repel, we will show by hand. Repel by this much, repel by this much. We should know some formula to find the magnitude. Hello?
Sir.
Yes, sir.
So that formula for magnitude of force was given by one scientist. Do you know the name of that scientist?
Coulomb.
Coulomb's. So for force, we have to study Coulomb's law of electrostatics. Very important. One numerical fixed can be asked from that. Just complete this much. Then I'm starting with Coulomb's law of electrostatic in scalar form and then in vector form. Just copy these 3 points. Yes, Vaibhav, you are understanding properly, Vaibhav?
Yes, sir.
हाँ, because you have exam on Monday ना, तो इससे मैं एकदम slow जा रहा हूँ. अभी class में बाहर हो जाएगा. Which chapters you have in the exam?
Sir, this chapter and motion in one plane.
Okay. Try to get full mark this time.
Okay, sir.
Last time 24 you got, na?
Yes, sir.
1 mark less. This time 25 out of 25. Let us try.
Done, sir.
state and explain Coulomb's law of electrostatics. State and explain Coulomb's law of electrostatics. According to Coulomb's law of electrostatics, the magnitude of force of attraction or repulsion between two point charges. When we say point charges means size of charge is negligible as compared to distance between them. So force of attraction or repulsion between 2 point charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of distance between them. So magnitude of force of attraction or repulsion between 2 point charges is directly proportional to the product of magnitude of two charge and inversely proportional to square of distance between them. Just write this much, then in notation we'll see. Heading is state and explain. Fixed to be asked for 2 marks in the exam.
sir.
Can I clear this now?
Yes.
So this force of attraction or repulsion were between 2 point charges. Let Q1 comma Q2 be 2 point charges situated in air or vacuum at a distance r apart. Therefore, by Coulomb's law, force acting between them, comma F, proportional Q1 Q2 by R square. So directly proportional to product and inverse. Inverse means 1 upon to the square of distance between them. Please copy till there.
Done, sir.
Therefore, F is equals to K into Q1 Q2 upon R square, where K is proportionality constant. It is given by K equals to 1 upon 4 pi epsilon naught, where epsilon naught is permittivity. This term is called permittivity of free space or vacuum. Its value is 8.85 into 10 raised to minus 12. K is 1 upon 4 pi epsilon naught, epsilon naught. And its unit will be Coulomb square upon Newton meter square. See, with this case 1 upon 4 pi epsilon. Epsilon goes up, F will come down. Therefore, Coulomb is Coulomb square upon Newton meter square.
That is
And
1 upon 4 pi epsilon naught.
so only for epsilon naught, 4 pi is the constant. So epsilon naught will have unit. 4 pi is a multiplier. Epsilon naught unit is 8 point, value is 8.85 into 10 raised to minus 12. Unit is Coulomb square upon Newton meter square. And K, when you substitute here, equals to 9 into 10 raised to 9 Newton meter square upon Coulomb square. This value will depend upon unit. If I change in another unit, this will change. In SI unit, K is 9 into 10 raised to 9 Newton meter square per Coulomb square. Everybody has followed this? Hello?
Yes, sir.
What is K? 1 upon 4 pi epsilon. And its value is how much? 9 into 10 raised to 9. And epsilon is called as what? Permittivity of free space or vacuum. Its value is 8.85 into 10 raised to minus 12. These values you have to memorize. Still any doubt? Anybody facing doubt till this?
No, sir.
Please copy till end. Aditya Pillai, Aryan Udane.
Yes, sir.
Aditya here, everybody
Yes,
has
sir.
followed now? Everything? This chapter
Yes,
following? Ah, yes, okay. Keep on asking if you have doubt, huh? One of the best chapter we are doing.
Yes, sir.
Okay. Shall I clear?
Yes.
Yes, sir.
See, every time there may not be air or vacuum. Sometimes charges can be in air, in water. Sometimes charges can be surrounded by some other material. So other than air also we can have surrounding medium. So what is that quantity called? Dielectric constant. Dielectric constant. That means if we have medium other than air, then it is called dielectric constant or relative permittivity. Relative permittivity. The ratio of, see, whenever relative means it is always ratio. Some connection, then only it is relative. Connection means compare. Compare means ratio. The ratio of permittivity of free space or vacuum to the permittivity of medium is called as dielectric constant or relative permittivity. Therefore, dielectric constant denoted by K is epsilon upon epsilon naught, or relative permittivity denoted by epsilon R is epsilon upon epsilon naught. Please copy. Completed? Hello, completed?
Yes, sir.
Define dielectric constant in terms of force. One, we got ratio of permittivity of any medium to the permittivity of free space or vacuum is called dielectric constant or relative permittivity. Same thing I want to write in force. When two charges are situated in air, then force between them, comma F. I am writing here A to understand charges are situated in air is 1 upon 4 pi epsilon Q1 Q2 by R square. Let this be equation 1. When charges are in medium other than air, then force between charges in medium becomes 1 upon 4 pi epsilon Q1 Q2 upon R square, equation 2. That means in place of epsilon naught, we have written epsilon. So F in medium upon F in air is 1 upon 4 pi epsilon Q1 Q2 by R square divided by 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught Q1 Q2 by R square. The first ratio is permittivity of medium, which is epsilon, and this is air, so epsilon naught. So can I say therefore F between two charges in medium upon air will be epsilon naught upon epsilon? Okay, this much clear?
Yes, sir.
Yes, sir.
This is nothing but K, na? 1 upon K, no? Because K is epsilon upon epsilon naught. तो ये उल्टा आया तो 1 upon K, K को डाइलेक्ट्रिक कांस्टेंट बोलते हैं. हेलो.
Yes, sir.
So K is nothing but FA upon FM. K मतलब डाइलेक्ट्रिक कांस्टेंट. Is FA upon FM? Not followed?
Followed, sir.
Okay, just complete till this, then I am giving definition of dielectric constant K in terms of force. This Sunday test will be on electrostatic, partly theory and partly MCQ. Only electrostatics. Tomorrow extra lecture evening 9 to 10. Is it comfortable to everybody? This is not doubt solving. It is lecture where we are going to do this electrostatic only further. Is it comfortable to you all? 9 to 10 evening?
Yes, sir.
Yes.
Okay. Lock this time for electrostatic. Once you are done, please tell, then I will clear everything.
Yes, sir.
Yeah, written full.
Yes.
Okay, others have also completed full.
Yes,
Yes,
sir.
sir.
Okay. Like thus, dielectric constant or relative permittivity is defined as ratio of force between two point charges situated in air. to the force between same two point charges situated in a medium. So ratio of force between two charges in air to the same two charges in medium is called as dielectric constant or relative permittivity. What will be unit of dielectric constant?
Unitless.
Unitless, because it is ratio of two similar quantities, that is force. So one line you can write down. It is unitless and dimensionless. It is unitless and dimensionless. एक line और लिख दो. It is also called as specific inductive capacity. So there are three names for dielectric constant. One is dielectric constant, other is relative permittivity, third is specific inductive capacity. Yes, shall I clear this now full?
Yes, sir.
So that's all for today. Tomorrow evening we'll meet for extra lecture